Hello everyone and welcome to a new In the Mail, the series that will touch both your passion for electronics and your bank account at the same time. We're gonna start with this USB power adapter and an interesting story. A few months ago I started using a wireless charging pad for my phone and I got a quick charge compatible pad capable of 10 watts. After using it for a couple of days I noticed a big issue. To paint you the picture, I was using this 5-port USB charger from Blitzwolf, which has been working great for the past 2 years, but here is the problem. I keep this under the bed and then I use a 2-meter cable up to the charging pad, which sits bedside. When my device is discharged, so it's pulling more current from the pad, that 2-meter cable creates a voltage drop, as you can see here in the video. The voltage entering the charging pad drops quite a lot, which makes the charging pad stop the charging because I assume it monitors the input voltage, and so the charging of the device might restart a few times and sometimes it stops and doesn't retry. The charger I was using was not quick charge compatible, it only had a 5-volt output. But I thought using a quick charge compatible charger that could go up to 9 volts might solve the problem. Because I ran some tests with a quick charge compatible power bank, and indeed having a higher voltage over that 2-meter charging cable meant less current, so less voltage drop. The problem didn't manifest itself anymore. So I ordered this charger, which is quick charge compatible. But it only does that on one of the 2 ports it has. This video is sponsored by JLC PCB, a professional manufacturer of printed circuit boards. Their website is modern and has convenient features like easy-to-use order form with built-in Gerber viewer, production process tracking, package tracking, and single-button reorder for previous orders without having to upload Gerber files again. Let me show you. Just this orange port is quick charge compatible. The other one is just fast charge. Just like a few weeks after ordering this, I see Blitzwolf release a new charger with 2 quick charge ports. So right now I have the problem solved, but if I ever need to add another wireless charging pad, I have to order yet again a new charger with 2 quick charge ports, or maybe use a shorter cable for the second pad. Anyway, I'll link both the 1-port quick charge and the 2-port quick charge USB chargers in the description below if you would like to check them out. Next up, a completely non-electronics related item, but I think it might be interesting at least for some of my viewers. This is a special tool for changing the oil on a DSG gearbox. It has just the right thread to allow you to screw it on the DSG gearbox, and this thinner end on which you can attach a tube, because for DSG gearboxes the official procedure for changing the oil involves feeding in fresh oil through the bottom of the gearbox. So I plan to do this myself. I got this adapter to help me. It was fairly inexpensive, under $6 delivered. But that's because this is a replica. Getting the original part from Volkswagen or Audi would probably cost you a bit more, and it would be the same metal piece, so I don't really see the point in getting the original here. In the past few videos I mentioned how I am in the process of building a resistance reference box, and I said I would like to run some silver wire between the terminals. I ordered this one from eBay. It's 1mm thick. It's what I need for the job because it has some stiffness which will create a solid structure inside the box holding the resistors. The only problem I would see with something like this is the quality. I don't expect this to be really silver because one roll, which I think it's 1 meter long, it's about $1.20 delivered. And it probably isn't very pure copper in the middle either, but since I'm having fairly large values of resistance in the box starting from 1K and I'm going to be using 4-wire terminals anyway, it shouldn't matter much. I could have used just plain copper wire, but I don't like how the copper wire would get oxidized over time, so that's why I went for this quote marks silver plated copper wire. Next up, adding to my growing collection of technical tapes, I have something new here and something old in a new size. The new roll is this electrically conductive mesh type tape. This stuff is great for shielding electric cables or shielding the interior of non-conductive enclosures. They say the fibers in this tape are nickel-plated copper on the product description page. Not sure whether or not that is true, but it is conductive and it is going to do the job for shielding. The second roll is just some cloth tape that I have shown before here on the channel, and this stuff works great. This new roll is 9mm width, which makes it easier to work with when wrapping in around the thinner wires. Both of these will be linked in the description below, and I highly recommend keeping stuff like this in the lab if you're doing electronics, because you will need it someday for some prototype, and it will make your work easier and also provide a cleaner look on that project. Next up, I hope you like stories, because here comes another one. I'm having some noise issues with the video feed when I fly my RC planes. So there is a brushless motor, there are wires carrying considerable currents which are pulsed at high frequencies. I have an analog camera and a video transmitter, and somehow the noise gets into the video feed. I've tried adding LC filters, ferrite rings on the power coming into these analog circuits. I tried powering the camera and the VTX from a separate power supply. I still have noise issues, so the next step is to try some shielding cable for the video system, as well as creating and making sure there is a single ground point where both the camera ground and the video transmitter ground will tie back to. So I thought I'd try this shielding cable from AliExpress. You can get it in a few different flavors. I have here a 4 wires model. So this one is 28 AWG in size. It was fairly inexpensive at around $2 shipped, and I'm really impressed with the quality. It's kind of soft. I was expecting the lowest possible quality for this price, maybe even fake shielding, but the cable actually feels nice. It even has markings on the side, so it's rated for 80 degrees Celsius and 300 volts. It doesn't appear to have a full woven shield braid. It's just a spiral shielding braid, but I guess this works as well. It's probably more expensive to have a machine that will produce that nice fully woven shield braid, so I'll give this a test, and I hope it will solve my problem. I think I made the right choice with the wire size. This AWG28 size seems to be pretty slim, and with 4 wires inside I can run VCC, ground, video, audio, and have another spare wire. So yeah, I'm pretty happy with this wire. I'll put a link to it in the description below. Next up, I'll show you this special tool that I have only recently discovered. I didn't know something like this existed until recently, and I imagine some of you already own or probably have seen something like this, but to me this is new stuff. It's a wire twisting tool for a hand drill. So I've seen several variations of this tool being sold online, but I guess this type of design is the most popular one. So the idea is to attach this to a battery powered drill tool, feed the wires in here, then use a pair of pliers to hold the wires while you twist them. This tool will automatically strip the insulation and twist the wires. So I'd like to give this a test and see what kind of results we get. This is the first time I'm trying it, so let's hope it's going to work okay. So let's see, I think you're supposed to feed like 1 wire to the side and maybe 1 in the middle, and then hold these with a pair of pliers and just twist. and I guess you can control the length by inserting the cable more or less. So let's try it. Oh, it doesn't work very well. Yeah, if it just rips your cables. So let's try this again. Maybe I did something wrong. I'm gonna try it one more. Gonna try it one more time. Maybe go with a lower speed. I'm not sure, or maybe faster, or maybe you're supposed to hold it right next to the end of the tool, like so. Let's try again. Going with a lower speed. Yeah, it did the trick this time, but I'm really not sure on the stress it puts on these copper wires. So yeah, I guess you have a good electrical connection in here, but I'm really not sure. I wasn't expecting so much stress to be put on the wire. So I'm gonna cut this again. Yeah, it's not good. You see, it's ripping my copper wire to pieces. So I wouldn't say this tool really works as advertised. Let's give it one more try. Yeah, so I guess it works if you go slow with the hand drill. I think I pushed it too hard on the first run. Now, standards might vary according to your location, so I'm not sure if this is accepted practice for mains wiring in your country. I don't even know if this is accepted practice here in Romania, but for hobby projects, this might prove useful someday. I wouldn't, however, like to use something like this to do the mains wiring on an entire home, for example. It's just, I don't like how the wires are twisted. It's putting too much stress on the copper wires, and I think you might get some weak points that might break later on. So yeah, I wouldn't use this thing for doing any serious work, but it was a new tool I discovered, and I thought I'd show it to you. It might prove useful for twisting wires in the future, for that one weird job that you have to do, that one weird project. So I'm gonna keep it in my toolbox, but I'm not going to use it systematically for wiring anything professional. For doing some high precision measurements on the workbench, you might want to use a coaxial cable to block some of the common mode noise being picked up by the wires used in the measurement. But usually multimeters don't have a way of connecting coaxial wires like BNC or SMA connectors. So I got a couple of these adapters. They feature two 4mm jacks with standard 19mm spacing, and they convert to a BNC connector. Most multimeters use standard 19mm spacing on the input terminals. So with the help of these two adapters, I can use a coaxial cable to do measurements connected to my bench multimeter. Now at some point I might replace these with something of higher quality, but for now these will have to do. My next item is a small GPS module. The part number is BN220 GPS, and apparently this module is just as capable as the Neo M810 module, because internally it uses the same chipset, the M8030-KT, but this module is usually cheaper than the Neo modules, but I suspect it's the same issue as with the fake Neo modules. It doesn't have that flash memory chip to allow you to upgrade the firmware, but usually you wouldn't require to upgrade the firmware anyway, so it's just as good. It's also quite compact. It's about 20 by 20 by 7 millimeters, which I think it's great for building a compact GPS tracker, and that includes this ceramic antenna. I plan on using this module on a new RC airplane that I'm building, but I thought I'd share it with you because there are a lot of projects where you might need a cheap and compact GPS module that just works. Next up, I have 3 DC to DC converter modules to show you. Let's start with this bigger one, which is based on the TP40057 from Texas Instruments, which is a 1 MHz 8 to 40 volts input DC to DC converter. In the case of this module, they tell you 9 to 35 volts input, and I think they lowered that input voltage because these input caps might not be rated for more than 35 volts, but you wouldn't want to operate those near their maximum rated voltage anyway, so I would stay on the safe side and I wouldn't power this with more than 30 volts unless I remove and solder some good known capacitors on that input. So this is a synchronous converter. As you can see, we have 2 MOSFETs on the module, but they do use a reverse polarity Schottky diode for protection right at the input. So this will have a voltage drop, thus a power loss will occur on that diode. It's simple. If you want to fix this problem, just bridge the diode if you want to boost the efficiency of the module. The next 2 DC to DC converter modules have this very small 8-pin style package controller. One of them has the numbers rubbed off, the other one doesn't, and it says 1AFRH. I did find this datasheet online which would match the specs. It's up to 16 volts input, 4 amps output. It's for the MP2214, but I'm not sure it's our device. It could also be some Chinese made chip, so I might be wrong here. But one thing is for sure, these are compact modules, not bigger than a fingernail, as you can see. Although they might not be capable of outputting usable 4 amps, I think they will do at least 2 amps. I really like the design of this module. For example, you could design some slots into your PCB matching this footprint, so you could insert these vertically into your PCB. And for this one, you could just mount it surface mount because it has these castellated pads and even a thermal pad. So yeah, I really like the design of these newer DC converter modules coming from China. This is our last item in today's video. It's a brake light flashing circuit, and initially when I stumbled upon this on eBay and ordered it, I didn't spend too much time reading the product description, but I was under the impression it's just a simple 12 volt flashing circuit. However, I later discovered that this works a bit different, so let me solder in some 12 volt LEDs on the output to show you how it works. So here is 12 volts from my bench power supply. This is the behavior. It will strobe the lights 3 times, then it will flash them 3 times again, but a bit slower, and then the light will stay solid on, which would make sense for a vehicle or motorcycle. You kind of want the brake lights to stay on after some time, and I was kind of hoping it flashes continuously, but it clearly isn't the case here. Now I'm kind of curious to see what they used inside this module, so let's try to take it apart. I'm hoping it's not potted so we can see something inside. Yeah, so exactly what I was fearing. It is potted inside and it feels like a soft compound. I mean, you want this for a product that's meant for use in automotive applications, because water will get in here and it's much harder to make the enclosure waterproof. It's much easier to just pot the whole circuit, so there's no way for the water to get to the actual electronics. So yeah, I would be destroying it if I would try to get through the potting compound, and we wouldn't probably be able to see much inside. Thank you for watching this video. That was all for today. Let me know in the comment section if you found something interesting. Send me some feedback by clicking the thumbs up or thumbs down button. And I'll see you next week with a new video.